Good morning, Honors Algebra 1. Today is Monday, April 27th, and we are beginning chapter 12. This is our last chapter, and it's a really important chapter. So let's get right into it. Quadratic equations. Now, this whole chapter, the whole chapter is on quadratic functions, and we're going to start out by talking about quadratic equations with perfect squares. Okay, well, what is a quadratic equation? It's an equation that has a squared term. It doesn't have a cubic term or a term to the fourth power. It has to have a squared term, and that's the highest degree exponent it has. All right, so here is an example, and we've done these before in previous chapters. X squared plus x minus 2 equals 0. Because I have an x squared term and it's the highest exponent is 2, we call it a quadratic equation. And we've solved this by factoring, right? We take the trinomial and factor it, and then it's set equal to 0, and so we have x equals -2 and 1 for the solution to this quadratic equation. In the last chapter, we also did a really simple quadratic equation, x squared equals 9. X equals positive and -3, okay? Because I'm taking the square root of both sides, this becomes x, but this side becomes positive and negative root of 9, positive and negative root of 9. So let's look in summary. If we just have an equation similar to this, x squared equals some constant, some number, there are 3 possible answers you can have. First of all, if k is positive, just like it is over here, okay? If k is a number greater than 1, it's going to have 2 real solutions, the positive and negative root of k. Just like here, k is 9, and the solution is 2 real numbers plus and minus root of k, or root of 9, which is plus or minus 3. Now, what if k is equal to 0? Well, in other words, what if x squared equals 0? Well, the square root of 0 is 0, so there will only be one answer, and that will be not k equals 0, but x equals 0. I'm so sorry. There's going to be one solution, and that solution will be x equals 0 if k is 0. All righty, so let me go ahead, and sorry about that. In fact, right here, I should go ahead and put my two solutions here. I should go ahead and solve it for x. I should say x equals positive and negative the square root of k. So let's just be careful on that. It's a solution, so it should be x equals, or whatever your variable is. X equals plus minus k, x equals 0. Now, what if this number is negative? Oh, if it's negative, then there will be no real solution. No real solution. That's all you'll write on your answer. And we'll do one of those on the flip side. Okay? So if this number, if I have x squared equals -4, it's impossible. No number squared equals -4, so I would put no real solution. Now in Honors Algebra 2, we'll learn about imaginary numbers, and then we'll have something new to talk about. But for this year, no real solution is a true statement. Okay, now let's go ahead and try a few of these. Now this one is similar to the other one we had, except we're solving for m. We have m squared equals 49. I always try to remember with an exponent of 2, a quadratic, there will be 2 solutions. The only time there's not 2 solutions is when you have your k value is 0, or you have a negative k and it's no solution. But most of the time, I'd say 9 out of 10 times, you're going to have 2 real answers. And in this case, it's m is going to be the positive and negative root of 49. M equals plus minus 7. Now, you do not have to write this middle step. You do not have to write it, but I'm just being really, really thorough here since we're learning it. Okay, now what if I have 5r squared equals 45? Well, the first thing I want to do is isolate my quadratic variable here, r squared. So I'm going to go ahead and divide both sides by 5, and I have r squared equals 9. So here I go. I'm going to take the square root of both sides, and so the square root of r squared is r, and r is going to equal the positive and negative root of 9, and it's positive -3, just like over there. Okay, now let's make it a little bit more advanced. Let's, instead of just having a plain old, I'm following my books over here. Okay, instead of just having a plain old x squared equals 64, I've got a binomial squared equals 64. But we're going to solve it the exact same way. And what we're going to do, if you take the square root of this term, think of this just as an x. Let that plus 6, don't let that stress you out. Just go ahead and treat this as your variable term. I'm going to take the square root and I get x plus 6. Just like over here, I had m squared and it's going to go down to m. Now on this side, I am going to take the positive and negative square root of 64. On the side opposite your variable, you always take the plus minus root. Okay, now let's go ahead and continue on. So now what I have is x plus 6 equals positive and negative 8. I've just simplified my root. And now I'm going to isolate my variable. Well, so x is going to equal, bring this over, negative 6 plus minus 8. Now you can't box that. That's not simplified. Okay, but we can do the math. And so I have x equals, well, let's first do negative 6. Doesn't matter. I'm going to do negative 6 minus 8. Well, negative 6 minus 8 is going to be negative 14. Now, what is negative 6 plus 8? Positive 2. And I have two solutions. You can list either one first. Most of the time, you'll put your smaller value before your larger value, but I'm not going to be picky about that, especially this year. Okay, so if you were to go ahead in here and put negative 14 in here and positive 2, you would see that both of them squared gives you a positive 64. Okay, let's go ahead and go to the flip side now and see what we have. Let's go ahead and talk a little bit more about perfect squares. Well, we've talked about perfect squares, 1, 4, 9, 16, 25, 36, 45, 64, and so forth and so on. Those are numerical perfect squares. But let's talk about some variable terms that are perfect squares. Well, x squared is a perfect square of x. The binomial x plus 2 squared is a perfect square of x plus 2. 5x minus 1 squared is the perfect square of 5x minus 1. Now, let's go ahead and try to remember that we call this a perfect square binomial, okay? Why did we call this a perfect square binomial? Because it can be written x squared plus 6x plus 9, a perfect square trinomial. It's this perfect square trinomial because it can be written as x plus 3 squared, okay? And what do we look for? First term is a perfect square, last term is a perfect square. Take the square roots of both of those and multiply them and you get 3x, double it, 6x, it's a perfect square trinomial. Let's look at this one, x squared minus 12x plus 36. Perfect square of 6, perfect square of x, 6x times 2 is 12x. Perfect square trinomial because it can be written as the perfect square x minus 6 squared. Notice the minus in front of the 12x matches with the minus 6 here. And here you have a positive 6x, so you're going to have a positive in here. So we have perfect square trinomials. Now you really understand why we call them that, because they can be factored to a term that is squared. Okay, now let's go ahead and solve some little bit more advanced equations here. Now the goal here is to isolate your perfect square. Let's isolate our perfect square. So here I have a perfect square, x minus 4 squared, okay? And I'm going to go ahead and isolate it by dividing both sides by 5. So I'm going to have x minus 4 squared equals 8. Okay, now let's take the square root of both sides. The square root of x minus 4 squared is x minus 4. On this side, I'm going to take the positive and negative square root of 8. Oh, okay, a little more complex, but we can do this. So now let's isolate x. X is going to equal, put your rational number first, plus minus. Now can the root of 8 be simplified? Now you probably know how to do this by now, but let me go ahead and write out the steps. It's going to be the square root. Do I have a perfect square factor here? I do. 4 times 2. So final answer, x equals 4, plus minus, bring out the square root of 4 and simplify it to the number 2, leaving me with a root 2 inside. And here is my solution to this quadratic equation, which I solved by isolating my perfect square and then taking the square roots of both sides, not forgetting to put my plus minus in front of my root on the side opposite the variable term. Okay, That's your answer. That's it. Let's keep going. Now, oh, I don't see something written as a term squared, but I should notice this square root is y, this square root is 3. 3y doubled gives me 6y. This is a perfect square trinomial. All right, now let's go ahead and write it as a binomial square. So this is going to be y plus 3 times y plus 3, or y plus 3 squared, equals 49. Oh, awesome. Now I have a perfect square here that I can take the square root of. And so I'm going to take the square root of this side, give me y plus 3. I'm going to take the positive and negative square root on this side. Okay, you can go ahead and write plus minus 7 if you want to. I'm just being really thorough here. And let's go ahead and isolate our variable. Y equals negative 3 plus minus 7. Now let's give our final answer. Y equals, I'm going to go ahead and do my negative number first. Negative 3 minus 7 is negative 10. Negative 3 plus 7 is 4. And those are my two solutions. You don't always get one negative answer and one positive answer. So don't think that's always going to happen. It's just happened so far. Okay, one more to go. Let's go to this last one over here. I have a lot, okay? Now, how would you solve this? If this were just 2x squared plus 15 plus 7, you would isolate your x squared term first. Your variable term is going to be isolated. This whole binomial, you're going to isolate. You're going to isolate the whole binomial squared. So, first thing I would do in any equation is I'm going to first add or subtract to get rid of this addend. So I'm going to go ahead and subtract 15 from both sides. So I have 2 times 3x minus 5 squared equals, well, 7 minus 15 is negative 8. The next step to isolate my binomial squared is to divide by 2. So I'm going to now have 3x minus 5 squared equals negative 4. Okay, now let's stop right here. If I take the square root of both sides, and let me go ahead and do that, I would have plus minus the square root of negative 4. This is not a real number. So when you get to the point right here where you have a term, your variable term squared is a negative answer, this is like k being less than 0. My k is less than 0. I have x squared equals a negative number, okay? And this is really not x, but it's 3x minus 5, okay? So but that binomial square is a negative answer. Can you square anything and get a negative answer? No, you can't. So I don't put anything except no real solution. So when my squared term is equal to a negative, it is no real solution, okay? And I'm sure you'll come across that in the homework today, and it will be due tomorrow. So I hope you have a great and blessed Monday, and I'll see you 11 o'clock at Zoom if you need me to help you solve any of these quadratic equations that have perfect squares in them. And otherwise, I'll be back to teach you again on Tuesday morning. So I hope you'll have a great day. Bye-bye.